hope you all are doing great amidst this pandemic. I'm Shruti, your host for the event, and I cordially welcome you all to the very anticipated DarkCON 2021, organized by Dark Army. Dark Army is an open source team of security enthusiasts eager to learn and grow, and this is an effort from our side to make a small contribution to the community. DarkCON 2021 is a two-day conference from 18th to 19th February that invites benevolent speakers to share their knowledge along with lots of interesting giveaways. Today is our first day of conference and we have our speakers XSS RAT, Pink Draconian, Mr. Imran and Shah Brazil. A token of gratitude for our speakers, our team Dark Army, and of course our precious audience. Glad to say you all make it possible. A special thanks to our sponsors Offensive Security, DigitalOcean, TryHackMe, BugCrowd, BurpBounty, Spyse, Intigriti and Pentester Academy. Also, don't forget to register for our 24-hour CTF that has a lot of interesting prizes as well. For any query, make sure to join a Discord server which is also in the description box below. So, without further ado, let's get started. Hope you guys will enjoy it a lot. We have our first speaker, XSS RAT. He is a YouTuber and a part-time bug bounty hunter. Welcome, sir. We welcome you with warm hearts, and it's a huge honor to have you in our conference for today. Also, he will be doing a giveaway. He will be showing 3 flags in his presentation slide, and the first person to email one to thexssrat@gmail.com will get 1 free course on Android hacking, 1 pack of stickers, and 1 coaching session for 60 minutes. So stay tuned with us and make sure you grab your chance. Hope you guys will learn and enjoy a lot.
Hey, what's up, you amazing hackers? It's great seeing you all here at DarkCON. Thank you so much for organizing this amazing event. I hope you guys will enjoy today. I'm going to talk a little bit about how CTFs can help make you a better hacker than you already are, you amazing hacker. Let's not waste any more time and let's get right into this, shall we? Now I'm going to also give you guys a few challenges to solve for yourself, because throughout this video I'm going to be typing some flags in my God knows where. If you see any of those flags, send them to me via email to the XSSRat@gmail.com. So that's the XSSRat@gmail.com if you ever see me typing one of those flags. Now, for the CTFs, you might be wondering how they can help make you a better, amazing hacker. Well, guys, I'm going to go over each of these categories separately, and then I'm going to tell you guys a little bit about how they can help you in real life and how applicable they are according to me. I'm also going to give you guys some more general tips about CTFs and how they can help you that we've gained from the community. So I hope you guys are ready for this, because here we go. Now the beginner tutorial is pretty basic. This is for 24 CTF. This is pretty specific for this website. And what 24 CTF basically is it's a website that hosts CTFs constantly. These challenges don't go away, but there's also no write-ups available for them, so you'll have to solve them properly. But the cool thing is that you have access to them constantly. You can also subscribe. That's going to cost you a couple of dollars, and you'll have early access and a lot of cool other things. But enough about that. As for the beginner tutorials, these are just the basic tutorials. Now for cryptography, what is this? You might be wondering. Cryptography is basically the coding of the encrypted messages. So you see here a few challenges like My Magic Bytes, The Impossible Users, Caesar Cipher, Exclusive Keys, Hidden Flag Bytes, Predictable Vectors, the Flag HMAC. So you see a lot of things in here, and you guys will probably already know what this means. So I would highly advise that you try this. So let's just see that you guys sent this over. Now, if you send in one of those flags, there are a couple of prizes you can win, which we'll detail at the end. But in here, it's mostly about points. So very important that you get those points, not to show off to anybody, but those points will help you keep a little bit of track of yourself. It's a little bit like gamification. You give yourself some rewards, some experience for completing these tasks. And it helps you keep track of your progress a little bit as well. Because one thing that you guys need to realize is as you guys keep on learning, everything that you learn is going to seem very natural to you. Like you've already always known it. And that's going to cause that you are going to start doubting yourself a little bit. Because you'll be like, I've been learning for a year, for 2 years, for 3 years, and it feels like I'm hardly learning at all. But the fact of the matter is that you're learning subconsciously a lot. And for cryptography, I think the real life applicability is going to be medium or high, especially since a lot of bug bounty programs choose to encrypt their data these days. So it might help you make sense of it all. And it's going to help recognize and decode those messages for you. That's going to be pretty important. And it's also going to show you the strengths and the weaknesses of these different algorithms. That's also pretty important, and it might help you later on. Now on this website and on some CTFs you also have a miscellaneous challenges. Everything that doesn't fit in a different category goes into here, of course. And then there's the network category. Now for networking, of course, anything networking related will go into here. IP tables, protocols, Wireshark analysis, all that stuff is going to go in here. And it's going to be important because, of course, this is really applicable in real life. All of this network stuff is going to help you a lot. And it's going to help you in a sense that everything is network related. Whenever we communicate with a website, whenever we communicate with a web server, everything goes over the network, everything goes over different protocols. And it really helps if you can analyze those protocols using Wireshark or whatever tool you're used to. So it will really help recognize the TCP/IP stack. It will strengthen your knowledge in it. Definitely a big plus for me. It will help you in those network protocols. It'll even help you with using the tool Wireshark. And in here you can see a pretty cool challenge, the custom protocol challenge. Pretty cool. I would highly advise you guys to check it out. Now there's also a DarkCON CTF ongoing, of course, which is awesome. By the way, guys, I really would advise you to check it out. As for networking, that would be about it. Now for the pwnable challenges, these are more like you're going to know them a little bit more as boot to root, although that's not entirely true because some of these challenges aren't complete machines. They're going to be like applications that you need to pwn. So you'll learn a lot of relevant skills, in my opinion. It's going to be at a pen test level that you're going to pick up skills in this category, if you ask me. So it's really interesting if you want to be a pen tester, if you want to be a bug bounty hunter. These things are going to help you quite a lot, and it's going to give you some experience in Linux hacking and Windows hacking and all of these different environment parameters. You're going to learn quite a lot, and it's going to help you a lot, in my opinion, as well. Now on to the reversing category, and this is, as the name says, it's a reversing. So you get a program, you have to reverse engineer that program and find the flag that way. So if you really want to reverse engineer these programs, I would say the real life applicability would be medium, unless of course you really want to become if you really want to become like, if you really want to become somebody who, there we go, by the way. So if you really don't want to become somebody who, if you really want to become somebody who goes into these malware analysis, for example, if you like doing that, if that sounds interesting to you, I would advise you to spend some more time in this category, as it will help you a lot. Maybe also crypto lockers, it might be interesting to you how they work and you might want to analyze them. So this category can definitely help you with that. Now it can help you with application flows. You'll learn a little bit about the different programming languages. You'll learn about data structures. You'll learn about decompiling applications, key check bypasses, a lot of things that this category can be useful for. So of course, if you're looking to get into that, if you're more looking to get into bug bounties, for example, this is a less useful category, but the next one, web, more than makes up for that. It's mostly website hacking, as the name might make you suspect. As you can see here, the challenges go from secure session, trusted clients, comparing pairs, to some really cool stuff from Mechanical Turk, for example, which has a custom CAPTCHA implementation, and then also a helicopter administrators. This is a really cool challenge, by the way. Highly advise you guys to try it. Now, of course, this is a really high applicability in real life for me, because a lot of targets are going to have a website, and it's also going to offer the biggest attack surface, in my opinion, since a lot of targets have it. And there's also a lot of different technologies that can run on that web server. So in real life, applicability very high for me. The skills you'll pick up are web application testing. You'll learn proxying. You'll learn some traffic intercepting, the different types of vulnerabilities. It'll help prepare you for bug bounties, even, in my opinion, and also for penetration testing again. Then I also have a category that's not on 24/7, which is steganography. Have to be careful that I pronounce it correctly there. And steganography is basically hiding messages in images. I like this category, although it's not very applicable in real life. It will teach you several skills which are really useful, like thinking outside the box, for example, logic reasoning, bitwise file analysis. Those are really important skills to have, in my opinion, because they'll really help you. Not a lot of people these days seem to have the superpower called logic, so the more we can train ourselves in it, the better, in my opinion. And also, guys, something we really need to talk about, in my opinion, is hosting your own CTFs, because we've talked about playing in CTFs, but let's talk about hosting a CTF, shall we? Because Uncle Rat has some experience with that as well. Now, as for hosting a CTF is not as easy as it seems. It gives you quite a lot of professional experience, because you have to manage a lot of things. These guys at DarkCON, they are doing an amazing job hosting this CTF and hosting these talks. Let me tell you guys, it's not easy. You have to contact all of the speakers. You have to gather sponsors. You have to gather something to hack, of course. You have to gather a framework like CTFD, for example. This is a really good framework. We'll talk a little bit about that later. But all of these different aspects, they teach you a lot about planning as well. And it's a really important aspect of your professional life. If you really like doing CTFs, and if you've done quite a lot of them, why not try your hand at organizing one of them? I know it's not for everybody, but it's quite fun, and I would highly advise it to anybody watching. As for CTFD, I also will use this in my professional life. As you guys probably know, I am creating a bug bounty course, and it's going to have a lab in it and a lab setup, and that lab setup needs somewhere to submit flags as well, so I'm probably going to look at CTFD for that. CTFD is a great framework, not just for CTFs, but for a lot of stuff. You know, you can adapt it, it's open source, so go wild, I'd say. Organizing the CTFs, real quickly about that before I move on to a different topic. You guys probably know that it's going to be a lot of hard work, and that's one thing that's the most valuable lesson, in my opinion, you'll ever learn in your life. The fact that putting in a lot of hard work is not going to give you immediate gratification. It's going to take a while, because planning this is something that takes months of work. It's not going to happen in a few days or a few weeks even. It's going to take quite a long time. And being able to plan out over such a long period with precision is very, very difficult. And it's not going to give you instant gratification. Your big gratification is going to come at the end. You're building up to this beautiful thing. And that's what bug bounties is all about as well, you know. It's not about picking the low-hanging fruit. It's not about hunting for bugs. It's about building up your mastermind, your master steps, and then executing the kill. But you have to plan it very, very carefully. The same thing as you have to plan CTFs very, very carefully. The same thing as you have to plan your participation carefully, because some of these CTFs run over a period of 24 hours, 48 hours, or even longer. And of course, you don't want to miss any hacking time. So you're going to have to plan pretty well. And maybe you even have a team that you can have a little bit of a switch off with. Somebody being awake while the other one sleeps, and maybe the other way around. Or maybe you guys want to hack together and rest together to exchange ideas better. It's going to be fun planning like this and working together in different ways, you know, experiencing that group dynamic. That's also super, super important about a CTF, because you can, of course, do a lot of CTFs alone, but a lot of them also allow teams, and that team dynamic is freaking awesome. You learn so much from your teammates, and you help each other out. That's what you do in a company as well. That's what you do in bug bounties as well. You help each other out wherever possible. You know, those skills, they're invaluable to me. There's so many things you can learn, but being able to work together with other people, that's a skill that's going to bring you super, super far in life. Now, on to the next section. And now another thing we have to talk about amazing hackers is the tools. One of my tools that I always use is one of the tools that you guys are seeing in action right now. If you guys look at the top right of the screen over here in this section, you guys will notice that there are some hidden fields there. That comes from Burp. Now I'm looking at a tool as well called HashPals. Well, at least it's a collection of tools. These guys are working on repositories like Name That Hash, Search That Hash, really good repositories. These are all tools that I use when I do CTFs. And when I do CTFs, I think tools, of course. And that's something beautiful as well, because all of these different tools, you'll get to know them, you'll get to experience them, and you'll get to see what they're all about. Now, if that's not good, then I don't know what is. If we look at Name That Hash, for example, this is a tool. I didn't find this true during CTFs, but I use it a lot in my CTFs. And in those CTFs, I've noticed some similarities in my bug bounties. That's gonna help me quite a lot, because I've seen some of these hash types that I've been unable to identify, and of course this will help me identify them. If I look at different tools like Nmap, Nikto, Nuclei is one that I know from a CTF, and I love the Nuclei tool. In fact, let's have a quick look at it right now, because Nuclei, what it is a vulnerability scanner, and you guys probably know it if you do some CTFs, and it works based on templates. It's really cool for CTFs as well, especially if the CTFs are from boot to roots, because I love those types of CTFs, of course. I like to play them quite a lot, and some of them revolve around these types of CVEs and vulnerabilities, so Nuclei is really good for that, and I love it when a CTF revolves around web as well, of course. And that's where this tool really, really shines. This is beautiful. I think web has one of the biggest attack surfaces out there. And that's where these tools are going to shine. Now, other tools that you can use, I'm thinking, for example, steganography. that's going to be a little bit less useful in real life. Of course, you're not going to need those tools as much, but it can be quite fun, you know? What if you want to communicate with a friend in this strange way and you don't want anybody else to find out? That's a cool way to look at steganography. If you're looking at an obfuscated JavaScript, you're going to look at JavaScript deobfuscator tools. Those are super useful in bug bounties. And if you're looking at those JavaScript obfuscation tools, you're also looking at the techniques, of course. That's only going to help you, because then you'll realize that some JavaScript obfuscation techniques keep repeating themselves. After you've seen a while of them, you'll note, oh, these keep repeating themselves. Maybe I can do something. Maybe I can write a little bit of a program of my own. Maybe I can create my own tool. And that's where the real fun starts, for me at least. Creating your own tools based on your own work experience. And you can also do that in CTFs. You can of course use tools created by other people. But where's the fun in that, right? Like at a certain moment you're going to have used all of these tools, you're going to know them. Maybe try to rewrite them a little bit. Maybe see if the source code can be adapted to your needs a little bit better. That's really, really useful, because if you're looking at the tools in that kind of a way, you're going to take that same mentality into bug bounties and into pen testing, where this kind of stuff really shines. If you're able to create your own tools, you have a big advantage over other hackers, of course. Why is that? Because other hackers are going to have to use the specific rules that the tool developers have set up for them, while you're going to create your own rule set. And that's where things get interesting, my dear hacker friends. Now, we also, of course, when we talk about tools, we need to talk about laziness, because in my opinion, tools make you a little bit lazy as well, especially in these like CTF types of scenarios. You're going to need tools quite a lot. It's not always possible to do things manually, and kind of promotes laziness in a little bit, in my opinion. So that's also why it's really good to write your own types of tools. And also like these tools where you can just, these challenges where you can just go ahead and write your own, where you have to write your own piece of software, your own piece of code. So with all of that being said, tools are freaking great, guys. It's really useful if you get to know all of them. It's really useful if you get to touch upon most of them. Super, super useful. Not all of them are going to be as applicable as they could be, of course, but it's up to you to adapt them to your own needs. You guys can program, you're hackers. If you can't program, you'll figure it out. Now, on to the last section. Now onto the community, because you guys have also given me some great advice as to why you love CTFs so much. Stefan Rose, amazing hacker. If you guys haven't checked out his channel yet, you guys definitely should. He said he likes pain, so I guess it also grows a little bit of a tough skin if you like CTFs. I think you have to. Manish says it builds intuition, which I totally agree with. When you're doing all this stuff, when you're hacking all of these different challenges, you start to get a sense of where you have to look for these vulnerabilities. It starts building a little bit of an intuition indeed, and it creates a way of thinking, he says, which is also very important in my opinion. It helps dig you a lot deeper, which is something that you need to train yourself in my opinion. It's also not something which we can explain very easily, which is why it's so hard, but it is definitely something you guys should be training yourselves into. It also removes the fear of source code, and now this one is a really good one, guys, because removing the fear of source code is something that a lot of people have. If you think about this massive giant JavaScript, for example, then you think, oh my god, I don't want to read this at all. I really don't. There's way too much obfuscation in there. It might even be chunked. But these challenges show you that as long as you go through these scripts step by step, logically, you're going to have a lot of good things come out of that. So it also helps you build your own tools in a way, because some of these applications, some of these targets require automation. like this. If you can solve our custom CAPTCHA addition equation 100 times in 30 seconds, you'll be rewarded with a flag. This is a good example of something you'll have to program, because we cannot do this manually, of course not. We're not going to be able to click it manually 100 times in 30 seconds. Thanks a lot for those tips, Manish. Really, really good. By the way, these tips are coming from the DarkCON Discord server. I would highly advise you guys to join that Discord server as well. It's pretty good, a really open community, and I really love it there. Now, as for our DXR10, my good friend said it enhances your problem-solving skills, which I totally agree with, by the way. Problem-solving skills are one of the hardest things to develop, and the fact that we have an opportunity here to develop them for ourselves is something that we should take with both hands. It really, really helps to grow your own problem-solving skills. And yes, guys, it is something that you can grow, because you'll definitely need that later on in life, not only in hacking, but in everything, if you ask me. Now, you can also, it really forces you to think outside of the box, which I also agree with. Most of these challenges can't be the more basic things, because a lot of CTF players, they've played more than one CTF, and they've seen all the tricks. So we're going to have to come up with some clever variation of those basic tricks to implement. And that really forces us hackers to think outside of the box a lot more than we're normally used to. Now, he also says that it exposes us to new issue types. Very, very true, especially with this stuff. If you're bored of the web applications, you can move on to the network applications. If you're bored of that, you can go to the ponables. There's so much categories to pick from, and so many different CTFs as well. Then there's also a great tip from a good friend of mine called White Wolf. Thank you for contacting me for speaking on this event. Some companies hire based off CTFs, he said. That's very, very true. I don't know about your country, but I know that in India, some companies will hire based on those CTFs. They'll issue their own CTFs, and they'll actually base their hiring procedures on those. Now, besides that, if you're a bug bounty hunter, sometimes HackerOne, for example, will host their own CTFs, where they will give out private invites for each of the flags. As for meeting new amazing hackers is also something White Wolf said, and it's also something I totally agree with. Your network gets expanded so much, and you never know who you're going to meet. One giant tip I can give you guys in life is that networking is one of the most important things that you'll do in your entire career. Build up a good network, and you'll have a lot easier time grabbing a good career. It's very, very important that you do that, because if you have to work yourself to the top, it's going to be a lot more difficult than if you have a good contact who you can prove yourself to and who can drag you along on board. So very important to build up your network. Now, as for Uncle Rat, I have seen this amazing tip from my good friend Insider PhD. And on KTG said, you will never feel like you've practiced enough, no matter how much you practice. I love that sentence because it describes me perfectly, guys. No matter how much CTFs I do, no matter how much port swigger labs I solve, no matter how many certificates I get, I will always feel inadequate. And that's okay, because you're allowed to doubt yourself. But you have to remember to be proud of yourself as well, and just get started. Even if you're scared of these CTFs, even if you're scared that you can't solve them, try it. Try it, and then after it's done, read a write-up and see how you could have improved yourself. Make notes, and every single CTF that you participate in, you're going to notice that you become a little bit better. And guys, it's going to take a lot of time to get good at this. Don't get me wrong, it's not going to be, oh, in 3 months I'll be an excellent hacker. Of course you'll be an amazing hacker in 3 months, but to be at the top of the top you need to work for years on end. And that's something that not a lot of people realize, but this field is so broad, there's so much things that we can learn that it's impossible to learn them all even. If you guys enjoyed this video, thank you so much for watching. If it's possible, I would enjoy a thumbs up. Thank you so much for attending this amazing conference. Thank you so much for hosting it. As for the prizes, if you submitted one of those flags to the XSSRat at gmail.com, what we are going to give away is, the first one is going to get a sticker pack. The second one is going to get my mobile Android penetration testing course for free. And the third one is going to get an hour-long coaching session with Uncle Rat. So I hope you guys enjoyed this video. I hope I'll see you on my channel soon. I'm the XSSRat. I'm out. Peace y'all.
That was a wonderful talk from XSSRat. We thank you for being a part of this, for spending your precious time with us, for delivering such quality content to all of us. It's highly acknowledgeable. Also, if you are interested further, you can go and check out his YouTube channel. And for now, we will move on to our next speaker, Pink Draconian. He is a YouTuber and he loves making content on boxes. So if you are curious, you can go and check out his YouTube channel too. Welcome, sir. We welcome you wholeheartedly and we are so thankful to have you here with us today. It's undoubtedly worth an achievement. I'm quite sure you guys will love it as well. Also, not to mention, do let us know your opinions in the comment section, and if you are learning and enjoying as well, don't hesitate to put a like on it. It would be very much appreciated from our side. So without wasting much time, let's move on. Up next, Pink Draconian.
Hello everybody, Pink Draconian here. So in a second you're going to be watching my talk for DarkCON. So DarkCON, it's the first edition of it, hopefully for many more to come. I hope you're really enjoying yourself. There's a couple of really good talks here that are you can learn a lot from, and I think that's the main goal here, to really learn about new things, and not only learn like specific things, but also learn a kind of process of learning so that you can learn more things in the future more easily, if that makes sense. So I think conferences are really good for that. And this year we haven't really had many due to the whole situation in the world, but hopefully through online conferences we can still get that feeling up, get that excitement up for all these talks and all these things that are going to be happening. And if you're participating in the CTF, good luck, may the best win. And yeah, have fun with my talk. Hopefully it's interesting to you guys. In the talk I will also be introducing myself, and let me know on Twitter or what you thought of it, if you liked it or not. And yeah. Hello everybody and welcome back to this new video, and today we are going to be talking about something a little different. We are going to be doing a talk about ELF binaries, and we're going to take a deep dive into ELF binaries to see what they really are and what they could mean to us in our lives. So without further ado, let's get started. So first off, a little overview. We're going to be doing a short introduction. We're then going to be talking about what an ELF file actually is, why we should know about them, why they're interesting to us, and what we can learn from them. We're going to take a tour and see how does source code become a binary, what happens with that. We're then going to take a deep dive into the actual structure of an ELF binary, and we'll see what happens when a binary gets executed, what are the steps that the operating system is going to take, and lastly, a short detour to talk about static versus dynamic binaries. Alright, so let's get started with this introduction. So I am Pink Draconian. I have a YouTube channel, I have a Twitter account, so follow me, subscribe. I make videos usually solving challenges and boxes from Hack the Box, from Cybersec Labs, from all different kinds of websites, and showing how they work. And I usually try to incorporate a education thing into it, so it's not just showing what the solution is, but also showing how do you get to the solution, and what does every step mean, and how does that work. So if you're interested in that, go check that out. I'm also very into penetration testing, so I have professional experience as a penetration tester and software developer. I am really into cybersecurity, and this year I am finishing my degree in AI. So that's who I am, but let's get into the ELF binaries. So first of all, what is an ELF file? So over 20 years ago, before I was even alive, in 1999, ELF was chosen to be the standard file format for binaries for Unix and Unix-like systems. So ELF stands for executable and linkable format. And it kind of defines a structure for binaries, but also libraries and core files. So when I talk about an ELF binary, that's not always the same as an ELF file, but this talk is mainly going to focus on the binary part, so I kind of interchange them. But so it defines a structure saying, okay, every binary is going to look like this. So this specification kind of allows the operating system to interpret these files and to interpret the underlying machine instructions, because a binary contains machine instructions that the operating system needs to interpret, needs to execute, so they need to know how that works. And an ELF binary kind of says this is a specification as to how they should be formatted and how they should be used. So ELF binaries are the output of a compiler, and usually when you talk about kinds of files, you can say, okay, this extension fits with that file. However, for ELF binaries, you can see there's a long list of ones that could apply, and even none can apply. So yeah, that's pretty much like a little overview about ELF binaries and what they are. And now we can go in deeper and analyze them. But first of all, I want to tell you about why you should be interested in this. Why should you know that? And pretty much everybody should know this. Why? Well, first of all, general knowledge. You are using a computer, you are doing something with security, something with computers, so it's always good to know at a low level how something works. Because if you know at a low level how something works, then you can abstract that to higher levels and you can apply that to different kinds of things, because in the end everything kind of comes down to the same thing. So it's important to know about as many things as possible. So I think just for general knowledge it's good to know this. However, also if you're a developer, it's very good to know this. Why? Well, if you write code, your computer is going to execute your code, but there's a lot of steps between them. And if you can kind of know what happens in between them and what actually happens with the code that you write, you obviously get a better understanding of what you're writing, making you a better programmer. Then we also have the standpoint of a blue teamer, incident response. And this is pretty much, well, you're working for a company or you're working for something, and you have to protect that. And attackers are going to use binaries to attack. Attackers are going to exploit binaries you have. And what if an attack happens and you need to see what happened, what went wrong, how did they get in? Well, then knowing about these files and about what these files do is obviously very important. Then the same goes for digital forensics and malware researcher. It's very obvious why they would need this. And then also red teamers and penetration testers, because we are obviously going to use these binaries to breach, to exploit them, but we're also going to create them to do something. So we're going to create binaries, but we're also going to exploit existing binaries. And in this video, I'm going to mainly focus on the red teaming and the penetration testing part of it, because that's what I'm most interested in. But first of all, some more general knowledge. We're going to see what happens to source code to become a binary. So for this, let's take C as an example. So we have source code written in C. And what do? Well, we use GCC, obviously, to get a binary. And what's GCC going to do? Well, it's going to first compile our source code into assembly code. That assembly code is something that we can see, for example, in Radare or in Ghidra. And it's something that we can still kind of understand. But then an assembler is going to take that assembly code and is going to convert that into object code, and object code is kind of the lowest level, and it's what your computer understands. And then lastly, you can have a linker that's pretty much going to link your object code to the reference libraries. So all the libraries it uses, it's going to link all of that together so it knows where everything is found, stuff like that. And that's how you end up with a binary. So it's kind of important to notice so you're aware of what is happening. And then this is also interesting because when you are going to be decompiling or disassembling a binary, for example, Ghidra can decompile, which is going to, disassembly is going to go from object code to the binary itself to assembly code. Assembly code is still hard to read, but then if you've used Ghidra before for reverse engineering, you will know that that is able to kind of generate back pseudo C code again. So that's going to be decompiling then. So it's going to be going from assembly code back into source code. So these are some terms that are quite important in the reverse engineering and binary exploitation fields. So moving along, the biggest part of this is going to be the structure of an ELF file. And the main structure is we have a header and we have some file data. And file data can be very extensible because the ELF file format is very extensible. It can be used for various different kinds of things. But we're going to focus on binaries, and for binaries we then have program headers or segments, section headers or sections, and then the actual data of the binary. And we're going to go into these a little bit deeper now. So first of all, the ELF header. So we can view the ELF header with readelf-h, and then it's going to show us what that header looks like. Now the first thing that we'll see is some magic bytes, and the magic bytes at the bottom here as well. You can see that we have 7F and then the letters ELF. So those are the magic bytes used by the operating system to verify that this is an ELF file. We then have the class, and the class is going to define whether it's 32 or 64-bit. So in this case it's 64-bit, and we can see that that byte is 02, so that is 64-bit. Then we have the data field here, and the data field is very interesting also for binary exploitation, because this is going to define whether it's the binary is using little or big endianness. So whether it's little or big endian, if you don't know what that means, maybe you've heard of least significant bit and most significant bit. So the endianness is pretty much going to describe how your data is actually being stored. And I have this little graph here that's going to better show that. So for example, if we use little endian, then that means that the least significant bit is going to be stored first. So in this data, 01, 02, 03, 04, the least significant bit here is 04. So we're going to put 04 in the first address, then we're going to put 03. So from the least significant bit up to the most significant bit. And then big endian is the opposite of that. And this can be a little bit confusing at first, because you would think like, why is this the case? Why would this be a thing? And to be fair, this is a thing that was first used a long time ago. Why? Because it was more performant for some systems to use little endian, for some to use big endian. So different creators of different manufacturers use different kind of stuff, and in the end, well, when you want to bring all of that together in one format, you need to be able to support everything. So that's why this is the case. But this is very important for binary exploitation, because as you could imagine, if you get back, for example, a leaked stack address, you need to know, well, is my binary little endian or big endian? Because if you, for example, think your binary is little endian, but it's actually big endian, the address you're going to get back, you're going to process that wrongly, and it's not going to make sense, and your exploit is not going to work. And that's why, for example, in pawn tools, when we unpack some data, we supply whether it's little or big endian, so it knows how it's actually how it has to handle them. And the difference between endianness is very simple, in that if you look at the source code for pawn tools, you'll see that this is the code that deals with endianness. So if endianness is little, it's literally going to reverse the data, where data is bytes, is an array of bytes. So it's literally going to just reverse that. So it's incredibly simple, but very important, because it can make a script not work, and you might not know why. Well, it might be because of endianness. So now you know where to find endianness in your binary. Next up, we move along to version, and there's only one version of ELF at the moment, with no real plans to get another one, so this is always going to be one. Moving on, we also have the operating system slash ABI, so OS is operating system. And then ABI stands for Application Binary Interface. Now, if you hear that and you think, what is that? But you may have heard of API, which is Application Programming Interface. Well, it's kind of the same as that. However, an ABI works at a lower level. So an ABI is a way for your operating system and the application to know what to expect from each other, to interface between each other. So to better understand this, we can obviously think about an API, which is also going to interface between software at a higher level. However, as a programmer, as a red teamer, as a penetration tester, this is not something that you're usually concerned with, because this is something that's really only the compiler, the operating system. Those are really the only. If you're writing compilers or operating systems, you're going to have to deal with that, but usually you're not going to get into contact with that unless you try to compile in different programming languages or for multiple compilers, stuff like that. However, that's incredibly rare. So usually that's really not something to be concerned about. Then moving on, we also have the type of the file. This can either be a core file, a shared object file, which is dynamic, and that's for libraries. Then we have exec for executable files and rel for relocatable files. And then moving on, we also see the entry point address, also very interesting because that is where the actual, where your program is going to jump to after it's done all of its preparation stuff. So that's where your actual program, your code, is actually going to be executed. That is the entry point of your binary. And this is also obviously interesting when doing reverse engineering to know the entry point, to know where it's going to start. And then the rest of this is all information concerning the other program and section headers, which we are going to jump into now. So okay, next up we have the program headers or segments. And the program headers show what kind of segments are used at runtime, and it kind of tell the system how to process this file and what to do with it. And for example, we see this interp here. This is going to tell, say, the location of the interpreter that is to be used with this and a path name to it. We have this load here, and this load is going to specify a segment from the file, from the ELF file, that needs to be loaded into a virtual address. So what's going to be happening is this is going to define the length that needs to be allocated. So it's going to allocate that length of space and then move a certain part from the file into that space. So it's going to specify what needs to be loaded into memory. So that's also very interesting to know about, what parts are being loaded into memory. Moving on then, I'm not going to go into everything, but then we have the GNU exception handler frame. This is also interesting because this is going to specify a sorted queue used for storing exception handlers. So when your program breaks down, when you have an exception, this is where these handlers are being stored and used. So I found that interesting. And then lastly here, I'm going to talk about the GNU stack. So this is going to pretty much define the stack, so where the stack is going to be stored, stuff like that. Basic stack information, and if you don't know what the stack is, at a very high level, it's a last in, last out kind of data structure used for storing variables, storing everything your binary needs to use, everything that changes during runtime. So imagine a stack as at a restaurant, a stack of plates that's going to, so if you take a plate from a stack of plates, you're going to take the top plate. If you put one back, you're going to put it back on top. So that's kind of how a stack works. So it grows and shrinks. However, in this case, we have to turn it around upside down because that's how it works here. And that's a stack. But there's something even more interesting here for us as pen testers or as binary exploitation people. And that is the fact that we see a small difference here. So right here, we see that it says read, write, execute. And on the other side here, if this pop-up would go away, yeah, we see that it only says read, write. So what's the difference here? Why is the stack on the right executable and the stack on the left not executable? And why is it important? Well, if you think about the kind of protections that you can have on a binary when you're doing binary exploitation, you might come up with the answer here yourself. And it has to do with the NX bit, the no execute protection. What is that going to mean? Well, if a binary has no execute enabled, that means that of all your memory, memory can either be readable, writable, or executable. So for example, the stack, in this case, the stack always has to be writable, because that's where you're going to be storing variables and reading variables from. If NX is enabled, then you cannot execute anything on the stack. Your program itself, the actual code, is obviously going to be executable, because that's what you're executing. Why is it important? Well, if we have a buffer overflow, and we can write what we want onto the stack, and we can overflow return addresses on the stack. If this NX bit is not enabled, we could put some shellcode on the stack, and then jump to that shellcode and execute it, because we can write there and execute there. However, if we enable NX, then we can write that shellcode still, but we will not be able to jump to that, because the stack is not executable. And that's what we see here. The binary on the left here has NX enabled, so the stack is not executable. And on the right, that's not the case. So that's very important to know about. Definitely when you're doing binary exploitation, you will have come into play with this. So it's very interesting to know how this actually works at a program header level. And then we're going to be moving on to the section headers of the sections. So these are pretty much going to define sections used for like linking and relocating. So I'm going to talk about a couple here. So we see .text. Where do we see it? There, .text. And .text contains the executable code. So the actual code that is being executed. We then also have .data. .data right here. .data contains initialized data with read and write access. And we have .row data, which is read-only data, so that's data that you can't write to. And then .bss is uninitialized data. And then lastly, one more important thing, or one more interesting thing here that you as a doing binary exploitation may have come across is the GOT, the global offset table. This is a table in a binary that's pretty much going to contain an offset for every variable. So if you need to know the location of a variable, you can go to the global offset table, and it's going to tell you the offset of that variable inside the binary. So for example, if you need to find where put is, a put function. So I said it wrong when I said variables. It's mainly symbols, so functions and stuff like that. If you need offsets to those, you can find them there. You will have come across this while doing binary exploitation. When you wanted to, for example, leak a libc address, stuff like that, you will have probably come across this. So that's something that that's also just a segment that you can find in your segment header. And that's pretty much all for the structure. So past that, we also have the data of our actual binary, of course, but that's something that lies outside of the ELF structure. So that's the whole structure, and I think for the structure, what you should take away from it is that a binary, an ELF binary, is just a file, and it's built by actual people, and it's pretty easy to understand. And we'll go into that a little more here, because let's say we wanted to write our own operating system. What would we need to do to be able to execute an ELF binary? Well, let's see. First of all, we obviously need to check the magic number. Is it actually an ELF binary? Then we are going to read the header to get all of that information, to know information about about endianness, all that kind of stuff. Next up is the program header. And from the program header, we are going to be determining what segments need to be loaded. And we need to load the load segments, and for them we need to allocate space, so allocate some virtual memory space, and then copy that segment from our file into that allocated space, because that's data that is needed. And then lastly, all that's left to do is to actually jump to the entry point that we can find in the header that we saw earlier. And that's pretty much, in very crude lines, what needs to happen in order to execute an ELF binary. So you can see it's not that difficult. It's a very extensible file format. So the specification is over 100 pages. It's really long. But when you look at it and when you kind of abstract it a little bit, you can see that it's not that difficult to understand. And what I learned from making this and from researching this is that I actually came across a lot of things that I already knew, but I could put in a kind of new light. I could understand more deeply, and from understanding it more deeply, I'm not going to remember that in the next 6 months, but that concept, that higher level concept, is still going to be better understood by me because I researched that deeper. And that's why I also think it's very important to go and do this. Research something that you think you might never use and see what you can learn from that. And maybe you might not learn nothing, but you might learn a lot. And is that a risk you're willing to take? Well, I think so. And lastly, to finish this all off, I wanted to talk about static versus dynamic binaries, because as a penetration tester, this is something that you will come across most likely. So binaries can either be statically or dynamically compiled. What does it mean? It all has to do with kind of the libraries that they contain. Why? Well, dynamic libraries, they require external components at the operating system. So they need to use things that are already present on the machine. So if you move a dynamic binary from one machine to another, it's going to use a different resource, and it's going to have to find that different resource on that machine. That is not the case for static binaries, because static binaries, they self-contain everything. So everything they need, they have in them, which means that the files are going to be way bigger because they have to have all of these external libraries, reference libraries in them. But they're also going to be way more portable, meaning that you won't get into a DLL or a dependency hell when moving them between machines. And this is interesting for penetration testers, because as a penetration tester, you're going to want to compile maybe an exploit, something locally, and run that on your victim. But your victim might not have the newest libraries available, or might not have something available that you need in your exploit. Well, if you statically compile them, that's not going to be an issue. So this is something to take note. If your binary doesn't work, check, is it statically compiled or dynamically compiled? And what happens if I try statically compiling it? And see if that makes a difference. And then the difference can be viewed with the LDD command on Linux. So just thought I'd add that. And that's pretty much it for this talk. I hope you enjoyed it. I hope you learned something, or at least gained some new way of looking at these binaries that you're running every day. And I want to end off with this slide again, and say that this is not usually the type of videos that I make. Usually I make walkthroughs through challenges. So if you're interested in that, check it out. I try to always go into depth for some of them, and I'm also going to, in my Introduction to Binary Exploitation series, so where I explain binary exploitation by doing actual challenges, starting from very easy, going more difficult. I will be referencing this and some of the stuff I talked about here in those videos as well, because for people that want to take that deeper dive. So yeah, follow me on Twitter, subscribe on YouTube, send me a DM if you want to talk to me, and yeah, I hope you enjoyed this video, this talk, and I hope to see you back for another talk in the future. So take care, goodbye.
That was indeed inspiring from Pink Draconian. It was really great to have you as our speaker for our conference today, sir. So a huge Thanksgiving from our side. For now, moving on to our next speaker, we have Shah Brazil. She is a senior cybersecurity specialist and an awesome enthusiast. Welcome, ma'am. We welcome you, and it's a huge pleasure to have you here with us today. And I'm pretty sure you guys will love her content a lot. So I wouldn't waste much time talking, and let's just dive into it. Also, a small reminder, don't forget to put your comments below and like our content back. As mentioned earlier, it would be very much appreciated from our side. So do let us know about your feedbacks and make sure you join our Discord server as well. So for now, stay tuned and enjoy.
Hi everyone, and welcome to Windows Artifact Analysis. I am Forensic Lady, here to take you through the various artifacts I analyzed during a digital forensics investigations, specifically to user habits and actions. The world as we know it runs on Microsoft Windows operating system. It accounts for almost 90% of the operating system in the market share. What to expect? We'll gain an understanding of the Windows operating system and the artifacts you may find, be introduced to the more common artifacts that you may encounter, and learn how these artifacts are used in investigation. By the end of the video, you should have gained knowledge on understanding user profiles and their default file structures, understand the importance of Windows Registry, knowing how to identify last login and password changes, as well as determining if the user had knowledge of files using Thumbcache, browser history, MRUs, the recycle bin, and link files as a reference. And lastly, we will look at program execution artifacts and USB or attached devices that can be linked to the machine. First, we need to understand user profiles and their default file structures. When the Windows operating system is installed, it creates a default folder structure in which to store user and application data. Sometimes, just looking at the folder structure, you can tell which version is installed or not installed. When you are looking for user account profiles, the location can vary depending on the version of the operating system. When the user first logs onto the system, it will create a user profile. That profile will then be used for any subsequent logins and is now the user's environment for the activity on the system. Different types of user profiles are also found. You have the local user profile, which is your basic default profile. It's created when the user logs into a computer for the first time. You'll find the profile stored on the hard disk, which is whichever medium used for the C drive. When changes are made to the profile, the changes will be specific to the user and stored on the local computer. Next, we have roaming user profile. This profile is an administrator created profile. It's network based. The profile will be downloaded to the local host when the user logs into the system. When any changes are made to that profile on the local host, those changes will be made to the server copy when the user logs off from the local host. This profile type removes the requirement on the part of the user to create a profile when they log into different hosts on the network. This profile can only be found in enterprise environments. Next, you have mandatory user profiles. This profile is a profile created by the network admin to lock users down to a specific set of settings when they use a host on the network. The user will not be allowed to make any changes to the profile without administrative approval. Any changes made by the user to the environment of the local host will be lost when the user logs off the local host. Temporary user profiles. These are fantastic. Not really. This profile is created when there's an error that occurs when the system is loading the user profile. When the user logs off, this profile is essentially deleted. You'll find the use of temp profiles on the computers running Windows 2000 or later, but not any earlier. Each user profile will have its own registry hive, also known as ntuser.dat, and it's mapped to the system registry key of each key current user when the user logs in. This hive contains the user's preferences and configuration settings. Each user profile contains the following folders: documents, music, pictures, videos. The app data folder is a hidden folder that contains user-specific preferences, and profile configurations, and is further divided into three subcategories. You have roaming. Roaming folder contains data that can be synced within the server environment. Data such as web browser favorites or bookmarks will travel with the user as they log into different workstations. You have the local folder that contains data related to the installation of programs. It is workstation specific and will not sync with the server. Temp files are also stored there. You also have local low folder, includes low-level access data such as temp files of your browser when running in protected mode. So what does it mean when I say that Windows Registry is the heart of Windows operating system? Microsoft defines the registry as a central hierarchical database. This database is used to store configuration information about users, hardware devices, and applications. But what does it mean to a forensic investigator? Windows references the information in the registry during operations. Information in the registry will contain profile for each user, installed applications, different documentation types, property settings for folders and application icons. The registry will also contain information about the hardware of the system and include network information such as ports that are being used. Essentially, it contains information about almost everything on the computer system. The components of the registry are found in the system root system32 config folder and are called hives. SAM, Security Account Manager, contains login information about the users. Security contains security information, potential password information, and you have software. It contains information about applications, application information, and default Windows settings. System contains information about hardware and software configurations. There's an additional hive, ntuser.dat, which is stored in the root of the user profile. This hive contains information about the user behavior and their settings. Another file of the hive formation is the user class.dat, which is found in the app data local Microsoft Windows folder of the user account. There you'll find information concerning the user access control configurations and information about the GUI display of the user experience. There are lots of tools you can use to help decipher the hives and registry keys. You can use the Windows default tool, Registry Editor, but there are other great open source tools such as Regripper and the Registry Explorer tool as well. These tools will be listed at the end of this video in a slide for your reference. There are several categories in which we look for artifacts. We look for account usage, file knowledge, physical location, program execution, USB or drive usage, and browser usage as well. Identifying the user behind the keyboard is one of the hardest things that you have to do when conducting a forensic examination. You'll have to parse through many artifacts to help make that determination. You'll want to gather as much information as you can about the user account in question and see where you can relate it to or how you can relate it to the physical person. So let's start with the user's last logon or password changes. In this image, I've already exported the SAM hive and opened it with Registry Explorer. Within the users folder, a subkey names list the accounts on the machine. It lists the names in English so that they can be easily readable. Wanting the account shown, one has the username of Donut Princess. The value for the Donut Princess subkey will point to the subkeys with the hexadecimal value. Here, Donut Princess points to X3EE. In the screenshot, you can see that the subkey X3EE has an F and a V value. You can also see their email address listed under the internet username subkey. To make it easier, you can run Regripper and see whether you can get an easier to read output. This screenshot is an example of the Donut Princess account. Regripper parses the data and presents it in an easy to read format. You can now see when the account was created, password requirements, as well as, in this case, it's not required, which means that there's no password or requires another sign-in method, such as PIN, the last time the user logged in, and the number of times the account was logged into. Beside the username Donut Princess, you see 1006 and an SID with a matching number. SID is a security identifier used by Windows operating system to identify objects within. This is how Windows addresses components internally. At the end of the SID is a relative identifier, RID, which is the last digit after the SID. As an example, 500 is the RID that would identify the administrative account for that system. Any guest account would have an RID of 501. Any RID in the 1000s, such as Donut Princess RID of 1006, means the account was user created. As more accounts are created in the system, the RID increments by 1. So if you can't find accounts between 1001 and 1005, it means that the account was deleted. Another source of information to help determine what happened on the system is the event logs. Windows categorizes events into 3 different classes. You have system, information generated by the operating system, application, information generated by the applications on the local machine, and security, information related to login attempts. You can find Windows logs in the C Windows System 32 Win EBT/logs folder. The most common excuse that a user gives when they're accused of using the system for criminal or inappropriate reasons is that someone else had access to their system. RDP, Remote Desktop Protocol, is a way to access a host from another location. The security log will keep a record of any access using the RDP protocol. So you'll be able to look for that type of event. If you look for the event ID 4778 and 4779, that would show you when the service connected or reconnected and when it was disconnected. Here we examine the security log for the event ID 4624, as this will tell us the username, date, and time, and the means of which the logon was successful. We use the native app event viewer on the Microsoft Workstation to view this. Here we note the logon type is 11, which means that it's cached interactive. A logon with cached domain credentials, such as when logon to a laptop when away from the network. We have the impersonation level. The impersonation level that allows objects to use credentials of the caller. You have the account name, the domain, and the logon ID. A logon ID is a semi-unique number that identifies the logon session just initiated. Any events logged subsequently during this logon session will report the same logon ID throughout to the logoff event, 4647 or 4634. Then you have the elevated token, which has a yes or no value. Yes, if the user is a member of the administrators, which is kind of, and the kind of part applies to the interactive logons. When you're an admin, you have a user account control enabled, UAC. Then when you log on, you actually get 2 logon sessions, one without the administrator's SID and related privileges in your security token, and another with all the authority. Everything you do happens under the unprivileged logon session until you attempt to run something requiring admin rights. After you approve the UAC dialog box, Windows runs that one operation under the other logon session. So in the log you see two of these events, one where the field is yes and the other with no. Next, we're going to do file knowledge. We're going to explore thumb cache, browser history, MRUs, recycle bin, and link files. First, we'll start off with thumb cache. Depending on the size of the thumbnail, you might have multiple databases with the same image, but with different sizes. It depends on the view the user selected when in Windows Explorer. The existence of an image found in the database is not substantial proof that the user knew the image was on the system. A thumbnail can be added to the cache without the user knowledge. Commercial tools can process the thumb cache without issues, but in this case, we're going to use an open source utility. You can use Thumb Cache Viewer. I'll have the link at the end of the session. As you can see, the thumbnail does not have the same file name as the source image. To identify the original file that was used to create the thumbnail, you need to look at the Windows Search Indexing database, which is the windows.edb database. Note that the name of the thumbnail is made up of hexadecimal characters. You'll need an additional tool to find the information about the image used to create the thumbnail. You can use the ESE database view. I'll have the link at the end. The thumbnail name is made up of hexadecimal characters, FB30, CE, 1B, so on. To locate it, we need to reverse the values to search the database. So we have to search for 1B, 55, 85, and so on until you find a match. As you can see, we have a match. By opening the item, you'll be able to find the name of the original image, where it was saved, who owns the image. So make sure to check the system thumbnail cache ID to verify that you're looking at the correct file. Microsoft uses the same method to record a user's activity and internet history as they use Chrome, Edge, and Firefox browsers. It records both local and remote file access. Most commercial forensics tools parse these super easily. Depending on which browser the user uses will depend on the location of the cached files. Here I just have Chrome, Edge, and Firefox as examples. Here we're using the ESE data view to show that the user Donor Princess went to login.live.com. The sync time, creation time, and access time are displayed in epoch time, nanoseconds format. To decode this, you can use the open source tools such as the epoch converter. The database will also hold information about offline HTML files and if they opened PDFs, JPEGs, or doc files within the browser. MRU, also known as most recently used, is a list of recent used files that are stored in the user's ntuser.dat hive. When you open an application, you see the history list of prior files that have been used by the application. You are looking at an MRU. There are many MRU lists stored in the registry file, and you can use regripper to rip the ntuser.dat file to find them. Here's an example of an output. It will list the last 20 files opened and saved via the Windows common dialog, so the open save as dialog box. Another key to look at is the recent docs. This key contains a list of files that were executed or opened by the user through the Windows Explorer application. You will also have subkeys based on the file extensions, listing those files that were executed or opened. The system will store the entries in chronological order. When you're looking at the last entry or modified time of the key, it will correspond with the last entry on the list. And this key can keep track of the last 150 files. These are examples of subkeys that I mentioned earlier. You have examples of CSV files, doc files, and additionally, you can see when the user opened folders on the system. Entries of potential interest would be OneDrive or Cloud directories. When I see artifacts showing that the user used, or there's a use of a cloud storage, it provides additional locations that I will have to locate and acquire the digital evidence to continue with an investigation. So now that we can tell what files the user uses, what about the deleted ones, which is the most common? The recycle bin is a holding area for a file and protects the user from their own actions or misclicks. It provides an intermediary step when the user deletes a file, so in case you change your mind. The bin is a hidden folder stored in the root directory for every fixed disk. There will be subfolders named with the user's SID. When a user deleted a file, the original file gets renamed and becomes part of a set of recycle.bin files. The system will rename the original file with a $R followed by 7 random alphanumeric characters for a file name. The file extension will remain the same. The system will create a second file that starts with a $I followed by the same 6 characters as the related $R file. The second file tracks the time of deletion and the path of the original file location. If a user deletes a directory, the 2 files, $R and $I are created, and the R will contain all of the subdirectories and files with their original names. So what happens when a user empties the recycling bin? The system will update that the fact that the clusters are now available for use, and until the system overwrites the data, you may be able to recover data from the unallocated clusters. But just remember that the $I will be resident data in the MFT, so the master file table. If it's emptied, you might be lucky with other artifacts referencing the file, such as link files. Link files are used by the Windows operating system as a shortcut or link to files, applications, or resources. These kinds of files contain great information such as file MAC times, file size, file path, volume details. This info will remain even when the original file has been deleted. The system will create a link for every time the file is double-clicked or when using the file open dialog box. Using an LECMD tool or Link Explorer command line tool, you can gain more information about the link files such as the relative path, directory, block information, and more. This can be very useful to tie knowledge of a file to a user. Unfortunately, the option of creating link files can be turned off by the user or sysadmin. Another artifact that is similar to link files, though, is the jump list. Jump lists are introduced with Windows 7 and are very similar to recent folders. It allows users to access frequently and recently used files from the Windows taskbar. Even if the user clears out the recent folder, it will not clear out the information stored in the jump list. The jump list can be found at the path noted on the slide. There are also 2 types of jump lists. There's an automatic one, system-created records, records information about file usage, and custom, which is application-created. It records task-specific information about the application. Here's what the entries look like in the automatic destination folder. Inside, you'll find jump lists. You can tell by the -ms. The system names the jump list based on the ID. For example, A5-2B0784, that one, which is the second one, that one is a Windows 10 Microsoft Photos jump list. And you can search the jump list on community.malforensics. I'll have the full link at the end of the session. Using Jump List Explorer, the following is the information contained in the MS file. You can see the user accessed the file 4 times using Microsoft Photos. Most commercial software will be able to parse out a jump list, but here we're using the open source option by Eric Zimmerman's Jump List Explorer. Jump lists are artifacts for files, essentially. You can explore more by using shell bags to determine which folders the user accessed, which can be parsed out from the user class.dat file. Program execution. Program execution artifacts indicate programs or applications that were run on the system. The user could cause the execution, or it could be an auto start or auto run event managed by the system itself. Some categories overlap with the file knowledge category we recently touched on, so just be aware that the artifacts from recent apps, jump lists, MRUs, will also contain information about program and application activity. So let's dive into user assist. User assist is a registry key in the user's ntuser.dat file. It can be found in the path posted here. The key tracks the GUI-based application that were launched in the system. The system encodes the data in the key with RAT13 encoding. Regripper will decode that data automatically. This is what the output from Regripper looks like. You can see the date and timestamp of the last execution in the path of the executable. The number within the parentheses indicates the number of times the user system has activated the executable. Next, we have a screenshot represents the output you get from Regripper of shimcache. The artifacts found in shimcache can provide supporting evidence of the other artifacts found throughout the system, that is the registry, event logs, and file system, and so on. We use this as a validating tool to ensure that we're looking at the correct information. Lastly, we have user USB attached devices. Sometimes the user will have programs or files contained within a portable device. There are several security risks associated with a USB device. They're small, they're portable, they have high capacity. These days you can get over 128 gigs. They can be used to exfiltrate data from any organization, or they can be used to deliver malware to an org to compromise its security protocols. As a digital forensics investigator, you'll want to know whether there were any USBs attached to the host that you're examining. There are 2 key registry keys that we would want to examine here. The first one is USB, and the second one is USB store. They're obvious, but you still need to remember to check those. The USB and the USB store keys identify the USB devices attached to the system. You can see that there were 2 USB devices attached to the system I'm analyzing at different times. You also have different volume serial numbers and the last write times for when the system accessed the devices. Make sure to note that the volume serial number found on the registry is not the physical device serial number. Looking at the USB store key, we get additional information about the devices, including the commercial name and the device. We can also confirm the serial numbers of the devices with these 2 entries in the system hive. So that's a wrap. We went over a lot of information during this presentation. We discussed how to locate artifacts on Microsoft Windows-based operating system to determine the subject's capabilities in the matter being investigated. I showed you different categories of artifacts and what actions of the user or the system they represent. Using the knowledge you've hopefully gained from this video will allow you to quickly determine which accounts were active during the time frame you're investigating and whether there was a removable storage device involved in the incident. You should also be able to analyze an artifact and determine if the user had any knowledge of it Today, we only used open source tools, which should give you a better basic understanding of what a commercial tool is trying to accomplish with added knowledge of where to look for validation. So congrats, you now know how to find and analyze digital evidence found on a Microsoft operating system. So I want to thank you for tuning in. I hope you learned some new techniques while I rambled about artifacts. If you have any questions, you can always connect with me via Twitter or LinkedIn. My Twitter handle is @ForensicLady, and you can get me at linkedin.com/in/Shannon Brazil. And as promised, here are the resources and tools that I use throughout the presentation. Thank you.
That was a splendid talk from Shah, Brazil. And now moving on to the last speaker of the day, Mr. Imran. He is a 21-year-old security researcher from Kashmir. He has been into bug bounty industry for 3 long years and he loves talking about bash, security and automation. Welcome, sir. We extend a warm welcome to you and it's a huge honor to have you here with us in our conference today. Also, I would take this opportunity to announce Dark Army is doing a giveaway of BugCrowd t-shirt, so make sure you are attentive enough during his talk and grab your prizes accordingly. I would also like to thank our precious audience for being so cooperative and supportive right from the beginning till now. It really means a lot and a huge Thanksgiving on behalf of Dark Army. Also, don't forget to join our Discord server to remain updated about various events and activities. Do let us know about your opinions in the comments section as mentioned earlier 1,000 times. Also, if you are really enjoying this content of us, do not hesitate to put a like on it. It really means a lot from our side. It's a huge request from us. Please let your feedbacks reach us. So without wasting much time, let's get in and hope you guys will enjoy it as well. We all together learn and grow, so enjoy.
Hey guys, this is me Imran Parray and welcome to my talk Bash and Recon. First of all, I would like to thank the whole organizing team for organizing this awesome event, and I would like to thank everyone who is here right now listening to me. I'm really thankful that you guys are interested and attending this event. So we're going to be talking about Bash and Recon. So this is going to be the agenda of the talk. So first of all, we're going to be talking about first Bash, and then why did I choose Bash, and then some basic concept about Bash like pipelining and redirection. Then we are going to talk about aliases, and then some Linux utilities which can be useful to build automation scripts, some text processing utilities like sed, grep and awk, and some file processing utilities as well. So after that, we're gonna have a quick demo about how to create your first automation tool, and then that will be an end of our talk. So first of all, who am I? My name is Imran Parray. I'm a founder of Snapsack. I'm an part-time security researcher. I'm also a bug bounty hunter working on BugCrowd and HackerOne. And actually, I finished my BE this year. I do a lot of web development and automation. So what is bash basically? So this is the definition from Wikipedia. Bash is a command processor that typically runs in a text window where the user types that causes actions. Bash can read and execute commands from a file called a shell script. So basically what happens, bash is actually a command processor where user is allowed to type several commands, and the respective binaries or the respective code gets executed at the back end, and the output, whatever the output is produced from that command is shown on the terminal. So we can create we can type several commands into a file and save those commands into a file, and then pass that file to a terminal, to a command processor, where those commands may get will get executed one by one. That's what we call shell script. So this is the basic definition of bash. How does it look like? I choose bash. Why not any other programming language? Why not Go? Why not some other programming language? I think the only reason that I choose bash is it's because it's pretty easy to create quick scripts in bash actually. So for example, if you want to send a GET request to a server or some endpoint which is producing JSON response, you can just simply pipe it to other tool and filter out whatever you want. And it's simple, and we have a lot of people who are building one-liners and tools that can be really built without using that structural programming. For example, if you have to do the same thing in Python, you have to import requests library, and then get a lot of do a lot of work, to be honest. So that's the only reason I choose bash. It's fast, it's simple, and everyone loves it. So getting started into bash, so these are some of the basic commands. For example, cd is used to change directory from one directory to another. For example, if you're working in some directory, if you'll type cd to other directory, so you will be your terminal will move from one directory to another directory. So ls is used to list the files. cp is used to copy. It takes two arguments, cp file1 and then the destination file. And move can be used to move files from one folder or move files from one location to another location. Echo is nothing. You can just echo data or reflect data from the terminal. So it can have a lot of uses. Don't think that it's not useful. We can use it on a lot of for example, if you'll type echo for example bash and recon, it's gonna print bash and recon on terminal. So rm is used to remove files from your file system. Jobs can be used to see the running jobs, and ps can be used to list the number of processes and their information, like the process id, the memory consumption, and a lot of other stuff about those processes. So these are some of the basic commands. I'm not going to show demos about these commands because I guess these are some really basic commands. Redirection and pipelining. So to be honest, I think redirection and pipelining is one of the best and one of the most powerful concepts when it comes to Linux. So redirection allows you to redirect the output of one command to be saved into a file or some location, whereas pipelining allows you to redirect the output of one command and pass it to another command for maybe you wanted to process that output into a second command. So in redirection, for example, let's say we have a command, for example, ls. So ls is actually a command which lists the files inside a directory, and you can see right now that whatever the output that was produced from ls command is actually shown on a terminal. But if you want to save it somewhere, so you can say redirect that output to a file. For example, let's say a. So as soon as I get a, you can see that the list of the files will be saved inside a file, because we have redirected the output of a list command to an a file. Simply, for example, now if I'm going to type in another command and redirect it to a, you can now, let's say we get a, and you can see that the previous output was actually overwritten because the single redirection says that you are overwriting whatever the data is present inside an output file. But if I'll do the same but use the double redirection and then cat a, you can see that the output of the command, the current command, the last command, was appended to an whatever the information, whatever the data that was present inside a file. So that's actually the redirection. So pipelining is basically an same concept, but here right now what are we trying to do is we are passing the output of one command, whatever the command we have the output, we're passing it to another command for maybe processing that output, or for maybe the tool need that output, and we are creating that connection between one different commands and passing data from one command to another command. So let me show you in demo. WC is basically a command which is used to list, I'd say count the number of words inside a file. For example, let's say WC file 1. So you can see that we have 10 words, 1 line, and 1 character, 10 characters inside a file. So if I cat the file 1, you can see that we have actually 10 characters and then space, I guess. So right now what I can do, I can do the same thing using pipes. So I'm gonna cat the file. So this is producing an output which is 1 to 9, and then I can pipe that output to a command and tell him to give me the number of lines. So it's gonna say we have 1 line, or give me the number of characters, we have 10 characters. So right now you can see that whatever the command we have, before the pipe, it produced an output and sends that output to an the pipe, the command which is after the pipe. So basically this is how pipes work. So here we have an example as well. So similarly we can use grep as well, and a lot of other stuff. So the other interesting thing about Linux is that we have aliases. So what is alias actually? So alias is actually you are creating a shortcut for an command. For example, if you have a complex command, or if you have a complex one-liner and you don't want to type it again and again, and you want to have a shortcut for this command, you can create an alias for that command. So let me show you. For example, if there is a command, for example, ls-l, so it's let's say it's a pretty long command and you did want to type ls.l. So for example, let's say you want to type, I don't know, maybe II, and it should execute ls.l. So you can create an ls and say I want to create an alias II, and I want to create it for ls dash l. So now we have an alias II. So as soon as I type II, it's going to execute that command. So but the problem is that these aliases aren't saved permanently. If you want to save them permanently, what you have to do is, because as soon as you close the terminal and then come back and open the terminal once again and type II, you are not going to have the same output. It will show you that that command isn't found, because as soon as this is saved as an environment variable, so as soon as you delete, you close the terminal, all those variables are gonna go away. So what can you do is you can open a file. For example, let's say I wanted to create you can go to bash rc. This is the file actually. So I didn't want to go down because I have some secrets and some tokens over there. So I'm gonna create it here. For example, I want to create I want to create an alias II, and I want to save it as ls-l. So now if I'm going to type II, I'll have this output, and if I close the terminal, open it again, let's say I want to open it here and type II, you can see that I have the same output actually, because right now I'm inside a different folder. So we have -l, you can see, so we have the same output. So shell scripting. So what is shell script? A shell script is a computer program designed to be run by Linux shell, a command line interpreter. So here you can see an example. For example, let's say, so basically let me tell you actually, what is shell script. So what happens, if you have a file and you have a list of commands, for example, if you want to do a task and you need to execute 5 or 6 commands, into that task, and you don't want to do this task, again and again by executing those 7, or 6 commands separately. So rather than, what you can do is you can create a file and, have all those commands into that file in an, sequential order and pass it to a terminal. So terminal is going to take that file, read the list of commands and execute those commands one by one, and produce and whatever the information you wanted to process and do the job for you. So that's how bash scripts work, a shell script works. So you're creating a shell script with a lot of, variables and commands and allowing interpreter or bash interpreter to execute those commands, in sequential order. The second thing that we need to talk about is command line arguments. So what is command line arguments? So basically, when we are creating tools or shell scripts, we need to make them dynamic. We need to make them, take an input from user and process that input and do the stuff according to that input. So command line arguments allows us to, produce or give input to an tool. So it's like an passing and list of arguments inside command when we are executing a tool. So let me show you how it works, pretty quick. So let's create a file, touch script2.sh and open it in Sublime script2.sh. So what happens, for example, let's say we want to create a tool which prints hello world. So make it a little bigger, hello world. So if I go back here and type, it's gonna print hello world. But now let's say I want to print the first argument of an command line. So as soon as I type, for example, let's say bash, so it's gonna say hello bash, because right now we are printing the first argument of an command line. So we can similarly print the second argument and third argument as well. So for example, bash and Recon. So this is the $1, $2, $3. So as soon as I type enter, so it's gonna say hello bash and Recon. So this is how command line arguments work. These are some of the most used command line utilities that we are going to use to create that automation script. So basically these are the tools which are used for different file processing and processing the output of previous command or processing the text and searching and gripping or cutting or removing some portion of a text. So all these processes, all these operations can be done with these kind of tools. So echo. So basically what does echo do? For example, it's just a tool which is used to reflect a kind of data on a terminal. For example, if you'll type echo A, it's going to print A on screen. If you'll type echo and nothing, it's going to print new line. If you'll type echo bash and recon, it's going to print bash and recon on your terminal. So pretty easy. But this can be used, when you want to, for example, if you have an automation tool and you want to add a new line which says, for example, hello world inside your output file. So you can say echo hello world, then pipe it to your file, or then redirect it to your file, basically. So this is how echo can be used. So the second tool is actually sed. So sed is basically a stream editor tool where a data or a stream of data is passed to a tool and different operations can be done on that data. For example, you can replace some text with other text, or you can delete the text, or you can find data based on regular expressions and remove it or replace it with other texts. For example, let me give a quick glance of that. So if we'll go to sed, so we have file 1 here right now. So let's say nano file 1. So I'm gonna add a quick new line here. Okay, so now if I cat, yeah, you can see that we have, for example, hello world, this is bash and recon, recon. This is file 1, 2, 3, 4, 5, 6. So for example, if I want to replace all the bashes with capital bash, so I'm gonna say, for example, sed, or I can use the pipeline concept. I can cat file 1, then pass it to the sed and ask sed, please replace, because this is what says substitute here, as substitute bash with bash. So you can see right now we had small bash here, but we have a capital bash here. But you can see the second, if we have bash anywhere, or let's say we want to do it for recon, so we want to replace with some R's. You can see that the first recon was replaced with you know, the capital R's, but we had other recons as well that were not substituted. This is because, you know, we aren't performing this operation globally, you know, throughout the whole data. So to do that, we simply have to pass G here. Now you can see, yeah, you can see that actually this is actually a recon we are searching for, because the second recon is capital R. I'm sorry for that. So you can see that all the recons are replaced with R's. So we can perform other operations as well. For example, if we have a number somewhere, you can see that we can use regular expressions as well. Or you want to, for example, say you wanted to add some kind of stuff at the beginning of every line. So you can say this actually defines the beginning of the line. For example, I want to add star and a space at the beginning of every line. You can see that we have the star and the space on the beginning of every line. So we can perform similar stuff. For example, we can use regular expressions as well. So if we have a number which is basically 0 to 9 anywhere, just replace it with star. So you can say we had 1 here and then 1 to 6 here, which are all replaced by stars. So this is how SID can be used to process text and replace text, or do a lot of, you know, other stuff. SID has pretty, you know, I can say that, you know, you can do a lot of advanced stuff, but right now, you know, I have to make this talk really short, so I'm not gonna dive deep into those options. But these are some of the options, you know, that can be used, you know, for text processing using SID. So we have a similar tool, but it's used to you know, find or extract or you know, I would say use regular expressions or find the patterns inside files or data or whatever the, you know, output that is given to the grep. So let's say, for example, so we have file here, let's say file 1. So I'm gonna say grep me all the lines which have, for example, let's say R. So you can see that we have only one line which have capital R. So I can say grep me all the files which have I. So you can see that we have files which we have 2 lines which have I's inside. So I can even use regular expressions. For example, grep me all the, you know, lines which have any kind of numbers. So you can see that we have the lines which have numbers as well. So we can do the same stuff. For example, if you want to give me all the lines which doesn't have numbers, this is actually and reverse search. So you can pass E is basically used to, you know, tell grep that this is a regular expression, this is not a normal string. So you can see right now that we have all the lines which doesn't have numbers because we have passed this V, which is actually the negative search, or which is actually inversing your results. So, you know, there are a lot of other stuff. You know, for example, grep dash is actually basically used to, you know, for example, remove all the, you know, new lines or empty lines, because you're saying match at least something, but if there is nothing inside a line, so it's not going to match that line. So quick trick to remove all the, you know, new lines. So this is how grep works. Again, grep is a lot deeper, and you can do a lot of other stuff with grep, but, you know, as a side, I have to make this talk precise. So let's move on to another tool. So cut is basically a similar tool, but you know, right now cut allows you to you know, divide your file into different sections, and then you know, do, you know, processing with those sections. For example, if we go back here and go to cut, basically So let's say we have two files here, file 1 and file 2. So if I'm going to read file 1, do we have file? Okay, we have file.txt. So you can see that, let me make it a little bit bigger. Cat file.txt. So we have a file which is actually in CSV file. So we have name, age, and height. So all these records are delimited by comma. So if we talk about this file can be divided into 3 sections. So we have the name section, we have the age section, and we have the height section. And talking about different sections, I mean to say this file can be divided into 3 sections based on a delimiter. So the delimiter that's used here is actually the comma, because the name is separated from age using the comma, and the age is separated from other 2 using commas. So using sed, we can use this concept and get a particular section of a file. For example, if I want only the name section of a file, so I'm going to say cat file.txt, then cut using the delimiter comma. So I'm actually dividing this file based on the delimiter comma, and then I want to get field 1. So you can see that we only have field 1, and I want to get field 2, for example. So we have field 2, or I want to get field 3. So we have field 3. Or let's say I want to get from field 1 to 2, or field 1 comma 2. So we can get any kinds of any kind of info sections of from that file. So the similar thing can be, for example, if we have file 2, you can see that we have the similar stuff, but right now we didn't have commas. The file, having a look at the data inside file, we can see that this file can be divided into 3 sections, but using the delimiter, using the space as a delimiter. So what I'm going to do here is cat the file 2, and then I'm going to say cut this file using the delimiter space, and I want section 1. So you can see that we are able to do the same step. So you can do the same stuff using any kind of delimiter, as soon as you have that kind of structured data where you are able to cut and file into different sections and get the first section. You can pretty much do everything. For example, let's say give me a pretty basic example. For example, we have a function date. For example, you wanted to get this the year or the current time, let's say. So what are we gonna do? We're gonna cut it. So we have spaces here in between. So we have space, and then I'm gonna get, this is the first field, second field, third field, fourth field, and fifth field. So I'm gonna get fifth field. So you can see as soon as I type F5 past the field 5, we're gonna have the fifth field of this output. So for example, if you want to have a current time, you can use this command. So this is how actually this cut works. So we have a lot of other options as well. So I would encourage everyone to go on Google, search about cut cheat sheets or some comprehensive guides about cut, so that you can dive deep into this tool. So the other tool we are going to talk about is curl. Curl is basically an command line HTTP client, I would say, because you're able to make HTTP GET requests. HTTP requests actually from a command line, from a tool, or from a terminal. So basically, what do I mean by that is, for example, if you are visiting www.google.com inside your browser, basically you are sending in kind of HTTP requests to an Google server on that address. So we can do the same stuff from terminal as well. So for example, let's say we have a so let me go here, for example. So I'm gonna say let's say I have 127, and then I have a demo.txt file. So you can see that this file says I'm demo file for bash and Recon. So curl allows us to do the same stuff, but from a command line. So for example, let's say I want to curl, and this Spyse the method that I'm going to use for the request. So I'm saying send and get request to this demo.txt. As soon as I type enter, you can see that the response is shown to me on a terminal. So basically the same stuff. It's a kind of HTTP client which is used to make HTTP requests to different servers and get the output and process that output and save it to the files, or I don't know, just do whatever you want after you get the output. For example, let's say I wanted to save it to a file, so I'm gonna save it to response.txt. So if I now get the response, I will have the response inside that file. So we have a lot of other options with curl as well. For example, let's say you wanted to see the header information, you can pass -i. Let's say -i. Now you have the header information, which is actually the response information. You can do, for example, capital I to only produce the headers, and you can change, for example, method from get to post. So you have the now this is actually the post request being sent to demo.txt, but right now it doesn't matter because server is responding us with 200. Okay, so you can do anything, pretty much anything with curl that a browser can do. So curl is basically an HTTP client which allows us to submit any kind of HTTP requests to an endpoints, to an servers, to an any kind of I would say entity that understands HTTP requests. So wget is similar as curl, but this is actually a download manager, or I would say, which is used to download files from terminal. For example, we had this URL. This is actually a file which is on my server. So what can I do right now? For example, mkdir, let's make a folder ddd and go to ddd. Now if ls, there is nothing inside this folder. So if I type wget get me this file, so it says that we downloaded this file and it's 100% downloaded, and it was saved in demo.txt. So as soon as I list the file, we can see that we have a demo.txt. On checking the content inside, we have the response of that file. So wget, just think of wget as an I would say a command line download manager, to be honest. So now we have understanding of how echo works, how sed works, how grep and regular expressions work, some of the basic some of the basic understanding of these tools, how cut work and how wget work, how curl work, and how zargs work. Zargs is actually another tool. I decided to delete the slide because of the time restrictions. So let's do one thing. Let's combine all these tools and build a kind of automation tool which can be helpful, because I have learned sed, I have learned grep, cut, but it doesn't seem to be useful right now. Let's do one thing. Let's build a Recon tool which does a lot of Recon automation when it comes to bug bounties. So it's gonna do a lot of I wouldn't say a lot of automation, but some kind of automation for us. So this is how we're going to build our tool. So our tool is going to have the target.com as an input, then it's going to find the subdomains, and then the list of subdomains will be filtered. It will be divided into live subdomains or dead subdomains, and after that all the dead subdomains will be left apart. We didn't need those subdomains because it's dead. We didn't want our tool to for example scan ports on dead subdomains, because it's useless to scan ports on domain names which are dead, because they didn't have a DNS record, so they aren't going to get resolved, and it will be in usage of time or usage of resources to scan ports or do dir search onto that domain. So we're going to remove them. So we're going to do two different things on live subdomains. We're going to scan the ports and see if there are any kind of files leaked, like .get or .api/api or any kind of files. We're going to perform port scanning and dir search. After that, whatever the output is produced, we're going to send it to a directory or a folder which will be called as report.txt. Okay, we have a file over there. So let's say it's just a folder, because we're gonna do that. We're gonna create that folder which will be holding all the results for the target.com. So let's do that. So I have due to time restrictions, I have already created a script, but I'm gonna do one thing. I'm gonna go through that script, step by step, and make another script, but I'm gonna copy paste commands, many different stuff from that script, because I cannot just, there are gonna be a lot of errors and a lot of other stuff while doing it live. So let's get started then. So going back, so yeah, so we have this Recon tool here. So if you can have a look here, is we need three different things here. The first thing is that we need to find subdomains. So we need to have a source to find those subdomains. We cannot just get them out of nowhere. So we're going to use some of the online endpoints like CRTSH or some kind of other endpoints, and then we're going to use dig to resolve those domains. If you have any subdomains, if that subdomain have an DNS record, so we're going to assume that subdomain has a DNS record, so it's a live subdomain, it's working, it does have a server or some kind of stuff. So if we didn't have an DNS record for that subdomain, we can assume this is dead, because we didn't have a DNS record, so it's probably dead. So after that, we are going to use Nmap for port scanning, and we are going to use FFUF for FFUF for actually directory searching, and we're gonna save that report to our final directory. So you can see right now we have we only need does search actually FFUF from as an external binary, because all the other tools will be present since I'm using Kali Linux. So let's do it then. So first of all, so I have recon.sh. Okay, so I have to open it in Sublime. So this is actually the tool. Let's say that we wanted to create another tool. Save. We'll create it as script.sh. Please note that I wanted to make this tool as simple as I can, so I'm not using any kind of advanced programming or any other stuff. So talking about how this tool is going to work, so I want this tool to be let's say sh script.sh then imran.com. For example, if you want to perform recon on imran.com, this is the way I want to work it, because I want to pass imran.com to a tool and it should start working on imran.com. So as we previously talked about bash arguments, command line arguments, so this is going to be the first argument of that script. So the first thing that I want to create is I wanted to create an output directory, because whatever the files that are going to be created regarding imran.com are going to be saved inside that folder, because I didn't want my main directory or root directory to be to have a lot of files, whatever the files that tool is producing. So let's open this Sublime script.sh, open it here. So the first thing that I want to do, let's move here. So the first thing that I want to do is see if there's any files with imran.com. If there's imran.com present, so it's going to remove it, because if we already have imran.com, we cannot create another folder. So if we already have previous records, it's going to remove them, and then after that it's going to create a folder with imran.com. So right now if we go back here and type the same command, sh imran.com, let's say hello.com. So you can see that we have hello.com, we have imran.com as well into this directory. So for example, if we have hello2.com, so we'll have hello2.com. So this is the first step. After that, what do we have to do is we have to start looking for subdomains. To do that, we have some kind of links here, which allows us to get subdomains. So we are enumerating the list of subdomains. So we are using 3 sources, that is CRT/SH, and we are using hacker target, and we are using ThreatCrowd, and whatever the response, you can see that we are sending get request to these endpoints, then enumerating all the information from these the responses that are coming from these servers. So let me show you some of the basic one of these, so that you can understand how am I able to get for example, let's take this one because it's pretty easy. So as soon as I go here, so it's going to replace our BugCrowd.com, our first argument with the domain. Let's say we pass BugCrowd.com. So as you can see here, it's gonna give me the list of BugCrowd.com, the list of domains and their IP addresses, but I just want the domain names here. So you can see that every domain is separated from its IP address using the comma. So I'm gonna say cut it with delimited comma, and then give me the first field. So as soon as I see here, we have the list of subdomains. So you can see that we are actually doing the same stuff here using the ThreatCrowd, and then I'm sorting and removing the duplicates and saving them to subdomains dot subdomains file. So similar stuff with this thing. So right now, if we'll go here, and please note that we are appending, we are not overwriting, we are appending all those subdomains to an .subdomains file. So if you'll go here, do the same stuff for BugCrowd.com, you can see it says we are enumerating subdomains. So it's searching CRT/SH right now, then hacker target, finding subdomains, then ThreatCrowd, and then it will exit. But if you'll go here, see the .subdomains file, we'll have all the subdomains that are found from these from these domains. Please note that we have this -n, so we are going to replace this -n with new line, because this is actually the new subdomain from here. So we can say for example, said replace all -ns with -n globally. So now you can see that we have all the -ns converted into new lines. So our output needs some kind of processing, because it has some kind of junk right now. So we are going to sum up, let's say I want to save all those subdomains. So right now you can see that all the subdomains that are present right now into .subdomains file, we're going to remove all the new lines, all the -ns that are present inside the file with -n. That's actually the new line, and then sort them, see if there are any duplicates, because we can have a subdomain from here, which may be duplicating each other. So we'll sort them and remove the duplicates, then save them the -n of $1 subdomains.txt. So we have a file subdomains.txt inside the target BugCrowd.com folder. So after that, we are going to remove .subdomains. So if we'll go here, remove .subdomains for now, then go here. So let's see if we have BugCrowd, remove BugCrowd. So go here and start the script. So it's searching subdomains, and then says we have found 33 subdomains with this script from 3 different sources. So if we'll go to BugCrowd.com, you'll see we have a file called subdomains.txt, and if I cat that file, we have all the subdomains related to BugCrowd from 3 different sources. So we have finished the first portion of our script, that is we are finding the subdomains. So we finished the subdomain portion. The second step we have to do is we have to filter the subdomains, the dead subdomains and the live subdomains. So to do that, so I'm gonna print some new lines here. That is just to make some spaces, make some new lines onto the terminal. And now what I have to do is I'll create this portion here and uncomment it. You can see right now we are printing, we are filtering the subdomains, and then I am reading the subdomains.txt, whatever the subdomains that we have, subdomains.txt file, whatever the subdomains that we have inside this file, I'm reading them, and I'm reading them as line. So this is going to loop, through all the lines that are present inside subdomains.txt, and each time the line will be the single subdomain. So I'm gonna say dig line short. So you can see, for example, if we'll go here, dig imran.com, which is an existing domain short, it's going to replace me an IP address. But if I have some unknown website, it's not going to replace me anything. So basically I'm going to say dig them, and if this command has any kind of input, then print that this is a live subdomain. So it's going to print the domain and redirect that output to livesubdomains.com. So we are printing something, but we are not printing it on a screen, so we are sending it to livesubdomains.txt. And if that file doesn't have anything, so this is going to be false. So we'll be executing this command as well, because this is like and is actually basically if this is going to execute, then only this will be executed. So if this is true, then only. But if there is any, like, this is not if there is no DNS records as well, so this statement is going to be false. We'll still print this is actually the dead subdomain, because we didn't have any kind of DNS records. So let's do this thing and see what happens. So I'm gonna run this script once again, go here, and okay, so we didn't have, because we are inside BugCrowd directory. So let's recon BugCrowd once again. So it's finding the subdomains, hacker target, CRTSH, then okay, so we have to make a little change here. So I'm gonna go here, chmod +x script.sh. So I'm gonna say script.sh bugcrowd.com. So right now we're finding the subdomains from different sources, and then it says we have some dead subdomains here. And as soon as we go to bugcrowd.com, you can see that we have two different files. We have live subdomains. So if we'll go here and see, we have word count, number of lines, we have 21 subdomains here. But if I'll get subdomains, number of domains inside that file is 33. So we have almost 12 subdomains that are removed from the subdomains.txt. So we have 12 domains which were dead, which doesn't have DNS records. So we removed them and saved the live subdomains inside this file. So our second step is that we have the live subdomains, we have the dead subdomains. We removed the dead subdomains. Now we have to do two different things. We have to do port scanning, and we have to do dir search on our live subdomain. So for port scanning, as I said, we are going to use nmap. So I'll go here. So I'm going to say port scanning. Let's say this is actually a comment. So to do that, let's say, for example, I want to copy this portion of encode which is responsible for port scanning. So I'm going to go here, uncomment this, and uncomment this line as well, because this will print some new lines on a terminal. So what does this tool do? So the first thing is, I'm reading the live subdomains right now because we want to search ports on live subdomains only. I'm reading live subdomains.txt, and then on each line, what am I doing? I'm printing, we are scanning ports on this line, and then appending this line to an nmap report.txt, and then I'm performing nmap onto that subdomain with these options. So we are scanning top 50 ports, and then I'm gripping all this, all the 0 to 9 which have lines, which have the port, the line which has this number, and then I'm gripping the open ports, and then I'm intersecting. So let me do it for you. So for example, let's say we want to do nmap localhost, for example. So we have some ports, but if I'm going to do this nmap, then append it, so it's going to remove all the junk here. So if I'm let's say I want to see only open ports, so I'm going to say grep open. So we have all these open ports. Now what do I want to do is remove. Now we have this portion only. So this is actually basically I'm removing all the unnecessary information from the output, and then I'm appending, you can see that I'm appending that information to an nmap report.txt, and after that I'm appending some new lines to this report. That's all we are doing this inside that loop. So we're gonna do this process for every subdomain that we have inside live subdomains.txt. So let's go here and run it once again. Yeah, because we are inside BugCrowd. Oh. Okay, so let's run it once again. So it's saying we are collecting the subdomains from CRT, from hacker target, from threat crowd. Now we are searching the ports. You can see that we are scanning ports on API or collateral.bugcrowd.com, all those subdomains. Please know that we have 21 subdomains inside live subdomains.txt. So we're going to do this process on every subdomain that we have inside live subdomains.txt. So if we go here, ls BugCrowd, we have another file that's nmap reports. So let's go to BugCrowd, then cat this. So you can see that we have the output of every file, every domain that we scanned from. So you can see that we have bounce.bugcrowd, we have some ports, we have some basic ports here. So we have the nmap, we have the port scanning as well on all those domains. Now the last step that we have to do is we have to perform directory search on these live subdomains. To do that, what I'm going to do is, this is actually the directory search code. So I'm going to take the code, copy it, go here. Please note that this printf is just to produce some, as you can see here, for example, if we'll go back, okay, I cleared the output, just leave it. So we are running a dir search. So how am I running the dir search? I'm again reading all the live subdomains. Then on each domain, what am I doing? I'm printing scanning file, then that line. So for example, if the first line is bugcrowd.com, it's going to print scanning files bugcrowd.com. Then I'm running ffuf, and the fuzz option, I'm fuzzing the bugcrowd.com/fuzz, because this is actually the fuzzing point where I want to brute force the list of files that are inside words.txt, and I am saving the output of that command, whatever the files or status code, everything that the information is being collected through ffuf. I want to save it into this file .ffuf, and I want to output .csv, and I'm running the tool into the silent mode. So these are all the options that I'm passing with ffuf. After that, I'm printing some new lines to ffuf, actually, which is actually the final file. So we have the final file ffuf, we have the temporary file for every domain, because we are saving that output inside .ffuf for a time being. Then I'm reading the ffuf and I'm saving it to an ffuf.txt. So this is how you can see that we previously discussed how redirecting files can be used to I would say redirection from one file to another file. This can be used in an complex commands as well. So here right now, why am I doing this? Because I want to save an output of this file, and then add some commands to an final file, add some new lines to an file, then add the the output of an first domain, then add some new lines, so that the output of the first command and the second command is a bit separated. So let's do one thing. Let's go here and run the tool once again. So if you go here, go back, ls, so remove BugCrowd, because this is our final trial. Remove hello.com, remove hello.com, remove imran.com, remove imran. Okay, so I'm gonna remove it. So if we go here, we have no folders. So please note that we are using FFUF, so we have to have this binary inside our root directory of the script. So if we'll go here and run the script on BugCrowd.com, so it's gonna find the list of subdomains from different tools, and we have found 33 subdomains for BugCrowd.com. It's gonna remove all the dead subdomains. It's gonna spin the ports on these subdomains, and after that we're gonna have DOS search or FFUF running on these tools. So we have scanning files on different you can see that it's producing, it's outputting the list of files that I have found on these so maybe it's gonna take a bit long because I have few files, the list of files inside my verse.txt. So you can see right now it's scanning list of leaked files or for directories one by one on these domains, because our loop, the while loop that we are running is on live subdomains. So every subdomain that's inside live subdomains have to go through this loop. So as soon as we have this this tool is going to finish, we'll have our final report inside BugCrowd.com. So we're gonna have a look at that folder. So okay, so it says done, Recon, finish it. So let's go to BugCrowd.com. So if we go here, so we have the first thing that we have is subdomains.txt. If we'll cat subdomains.txt, so we have the list of subdomains regarding BugCrowd. And after that, we filtered out the dead subdomains. So we had live subdomains. So live subdomains, it's actually, they are less in number as compared to the subdomains. After that, we decided to, scan ports. So if we'll go to nmap, you can see that we have the list of ports on every subdomain. So you can make this a little bit prettier when you are building your automation, but it's okay for in presentation. After ports, we decided to scan leaked files. So we have FFUF. Have a look here. You can see that we have all the files regarding these domains that we had. And the interesting thing here is that you can read this file and grep, for example, if you want to see only 200 responses. So you can see that all these lines which have 200 inside, you can see that I think API level up /API, it has 200 status code. I don't know what does it look like, so let's copy it and curl it. What is this? Where is it? Yeah, so this is actually the okay, so it does have some kind of data. So you can see that we easily managed to get all the 200 responses using grep. So this is how we managed to build and quick automation of our Recon methodology using bash. So so that's what this presentation was about. So I hope you guys really enjoyed this. So there's this final note that I want to tell you guys, that if somebody wants to create an automation which is more stable, more robust, and doesn't crashes, I would suggest you guys to use Python or Golang for that, because if you're building, you can have a look at Project Discovery. They have created those awesome tools. You can just follow the same structure of tools, and those tools are also open source as well. If you want to use the code, you can do it easily. And when it comes to building quick scripts, for example, you wanted to build a script which does remove the dead subdomains, or you want to write a script which generates an CSV token for you, you can do that with bash. But I wouldn't suggest people to build very complex automation. For example, if you're planning to automate your whole Recon process with bash, it's in my opinion, this is my personal opinion, it's a bad idea, because bash isn't stable. You don't have that control over the information, and it doesn't, I would say, it doesn't give you, full capabilities over the information that you are processing. So you always have to use external binaries, external tools to do that. Whereas, in other programming languages, you can have, very complex programming language to make your tool, as stable as possible. So that's my personal advice. So I hope you guys, really enjoyed the talk. So I want everyone to thank you again. If you have any questions, further questions, or you have, automation ideas, please do ping me on my Twitter. That's @Imran Parray 101. So we can just have a talk sometime. So thanks again. Have a great